BaCl2. Barium, we first find the metal, which is barium. It will be listed first. The atomic number is number 56, and this is our metal. So the first thing that we do, we find out, is it a transitional metal? So let's go back and look at your periodic table. So we find barium. Atomic number 56 is right here. Is it in the transition metals? No, it is not, is it? Well, those are the transition metals down here. So it is in group 2. So we don't have to worry about it. We go back and name it normally. So we name the metal, which is barium. Then we change the suffix of the nonmetal to IDE. So from chlorine to chloride. There's our answer, barium chloride. So this is one of the easy ones. On to question number 2. Ag2O. Ag is silver, which has an atomic number of 47. This is our metal. What's the first thing we do? Find out, is it a transitional? So get out your periodic table and let's take a look. Here is silver, number 47. It is in the transition. Answer was yes. Now we go to B. So we would find B. What do? We find it on the ionic chart and see if it has a Roman numeral. So let's take a look at your ionic chart. We are looking for silver, so we'll start off with number 1. They're alphabetical. Oh, there we have it, silver. And there is no Roman numeral. So no Roman numeral, we go to little number 1. What do? Name it normally. Take the metal, silver, add IDE to oxygen, so it changes to oxide, and there is our answer. Let's go to number 3. So I started off with the easy ones. As you can tell, there's a little bit more to this one. CuBr. We look at our metal. Copper, atomic number 29. We want to see, is it transitional? So look at our periodic table. We're looking for atomic number 29. And here we have copper. And yes, it is a transitional metal. Yes, so we will go to B. B. Now we go to the ionic chart. We see, does it have a Roman numeral? Well, I guess they're not all alphabetical because copper 1 is down here at the bottom. So we do see that copper 1 has a Roman numeral, so we know it's going to be somewhere else in this chart. Come through, yep, there it is right there, copper 2. Do we have a copper 3? I'm looking down. No. Do we have a copper 4? No. So now we get to do one with some Roman numerals. We had copper 1 that has a positive 1 charge, and we found copper 2 with a number positive 2 charge. So yes, it is a Roman numeral. Now we go to number 2. Number 2. Find the charge of the anion, or the nonmetal. So where is our nonmetal? Our nonmetal is right here. So it is bromine. So let's go find it. It'll be on the right-hand side of the periodic table. It is a nonmetal, or an anion. So we said it is a nonmetal. And our nonmetals are going to be over here on this right side. There's bromine right here. So what is our ionic charge or our oxidation state? -1. So remember that or write that down. So bromine is number 35 in group 17. It had 7 valence electrons. So we know the oxidation or the ionic charge is -1. Now, you might want to go in on your periodic tables if you still have your small periodic tables and go ahead and write down all those oxidation states so you can see those very easily. So we have bromine is -1. Now, we need to balance out our positive charges to our negative charges. Remember, they need to equal 0. So if we have a -1 on bromine here, we will need a +1 for our metal. So that means we're going to have a +1 on our metal. That way we get a balance. +1 and -1 equals 0. So we place the Roman numeral in parentheses behind the metal. So we would have copper 1. And then we change the nonmetal or the anion and add IDE, so it is bromide. Copper 1 bromide. That wasn't too bad now, was it? Example number 4. Here again, we have Cu, but it's Br2 this time. Br2. So something's going to be different here because a while ago we had CuBr. Copper is our metal. So we're going to go ahead and follow all the steps again, even though you could just look back at number 3. We ask, is it transitional? Now we just did it, so of course you know it is transitional, but I just want you to go through the steps again. There is copper, number 29, and it is in transitional, so it's going to have that varying ionic or oxidation state. So it is transitional, so we go to B. Here is B. I went ahead and wrote it down. Now we find it on the ionic chart. Does it have a Roman numeral? Now we already know it does, so let's just go back and check our ionic chart. Since it's copper, and we just did copper, we know we have a copper 1 and a copper 2. So, yes, we know it has Roman numerals, so we're going to go to number 2. Here's number 2. We're going to find the charge of the anion, which it is bromine. We've just looked at that one, and the atomic number is number 35. You know, it was in group 17, and it had a -1 charge. But now this is where writing your ionic formulas is going to come in handy, because now we're going to have to balance out the fact that we had 2 bromine. So bromine is a -1 charge, so if we have 2 bromine, then our overall charge for our bromine will be -2. That means we're going to need a +2 for our copper. So therefore we would use copper 2. How do we write it? We write the name of the metal. We put our Roman numerals in parentheses. That's important to remember. And then we add IDE to our nonmetal. That wasn't too bad now, was it? Just one left. On to our last one. Well, as you can tell, this one's a little bit more complicated. It's a little bit longer and a little bit more of a challenge. You'll be able to do it. Mn2O3. The metal is manganese, number 25. So, is it transitional? Always our first question. Let's go see. Here is our manganese, number 25. Yes, it is a transitional metal. Yes, it is a transitional metal, so we go to B. B, we'll go ahead and go to our ionic chart to see if it has a Roman numeral. We are looking for manganese. Let's go down and look through group 1. There we have magnesium. Nope, not that one. There's our manganese right here. Manganese has a Roman numeral 2. We know it's got to be somewhere else over here. There it is right there. So it will have ionic charge of +2 or +3. So now we have to determine if we're going to need +2 charge or the +3 charge. So it does have a Roman numeral. We're going to go to number 2. Number 2, find the charge of the anion. The anion is oxygen, so let's go check it out. We know oxygen is one of our nonmetals, so we can know it's going to be over here in this top part. There it is at atomic number 8. And it has a charge of -2. A -2. All right, so it has a charge of -2. But remember, up here, we have 3 of those oxygens. So we have to figure out what the overall charge is. So if we have 3 of those ions, and we're going to multiply it by what our charge is of -2, then our total will be -6 charge. Okay, so we have a -6 charge. We know that's a definite charge on that. So now we're going to have to take our anion, we're going to have to take and balance it out the oxygen. So we're going to need a total of +6. There are 2 manganese, Mn2. Here we have Mn2. So what charge do we need manganese 2, with a +2, or manganese 3 to be able to get a total of a +6, to be able to balance out our -6 on our oxygen? So we have 2 of these ions. So if we take 2 and we multiply it by the 2, we did magnesium, manganese 2, then that would only give us a +4. That wouldn't be enough. So we know it has to be manganese 3. Because if we take 2 times +3, that gives us a +6. So that would balance out our -6 on our oxygen. Well, I'm not able to slide this down. There we go. So our name is manganese, Roman numeral 3 in our parentheses. Why did we choose 3? Because we needed the +3 charge since we had 2 ions of manganese. And we go ahead and take oxygen and change that ending to IDE. All right, you ready to do some work? This is what your worksheet's going to look like. I'm sorry I couldn't get it turned around. Just look at it sideways. So you're going to go pick up this worksheet, Naming Ionic Compounds. Notice right here, whenever you pick it up, it says check your naming steps. So you're also going to go ahead and pick up this one, Naming Ionic Binary Compounds. These are the actual naming steps that I used for all the examples, and then it's also going to include all the examples we did. So I wish you good luck. I know you can get this.
Guys, just a correction. You will not need to pick this up. You already have this worksheet. This is the back side of your writing ionic formulas. Just wanted to let you know that. Good luck. You can do it.